Hello everyone, I'm Miftah Rahman from IPB University in Indonesia, now as a graduate student at Mississippi State University. I presented novel approaches in wood identification based on capacitance on behalf of Dr. Ratih Damayanti from National Research and Innovation Agency of Indonesia at Forest Product Society International Seminar 2023 in West Virginia, United States. As background, Indonesia is home to more than 4,000 wood species, with some playing significant roles in economic growth, while others hold potential for future utilization. Therefore, ensuring the sustainability of forest product diversity becomes a crucial factor. In fact, that is the reason why we have developed our Silarium Bogorians, which was established in 1914. The wood collection has played a vital role in wood identification process for research, education, as well as a bioforensic which involve wood as legal evidence. Recently, we have come to realize that it's not only wood that holds importance, but also the collection of bamboo and rattan. We have been actively developing this collection since 2016, and to date we have gathered 223 specimens representing 60 different species of bamboo and 62 species of rattan. To facilitate easier access to information, every piece of wood at Silarium Bogorians is equipped with a QR code. This innovative feature enables a seamless search process, allowing users to retrieve comprehensive information about each specimen with just one click. In response to government policy changes, we have established Silarium Indonesia in September 2022. This new Silarium expands beyond wood, bamboo, and rattan to include wood fossils and non-timber forest products. With 700 specimens from 146 species, we aim to provide a comprehensive understanding of Indonesia's diverse forest resources, especially from small islands and the country borders. The Silarium has three key purposes: research, wood identification, and forensic for combating illegal logging. It serves as a valuable resource for studying wood anatomy, acts as a reference for identification, and contribute to the fight against illegal logging. Recognizing the limitation of relying solely on physical Silarium and the expertise of few individuals for wood identification, we have a vision to make wood identification accessible to everyone. Our goal is to develop portable and easily accessible platform that allows users to identify wood anytime and anywhere. This initiative aims to democratize wood identification and provide broader access to this valuable information. Wood anatomy observation involves multiple steps and requires the examination of numerous wood features from macro to micro. It also involves the specimen preparation for thin sections which need quite a long time. To simplify this process, we have developed a smartphone application called ICO. With ICO, wood identification becomes more accessible and efficient, enabling users to conduct detailed observation and analysis conveniently on their smartphones. Since its inception in 2011 with 30 wood species, the ICO database has grown significantly. By 2018, it expanded to include 144 species, and in 2019 it reached an impressive 823 species. The database became publicly accessible during this time. In 2020, the ICO database expanded even further, encompassing almost 1,200 species. Additionally, more than 200 species were added in 2021, making it an extensive and constantly growing resource for wood identification. ICO's most important benefit is its ability to significantly shorten and accelerate the wood identification process, making it as easy as possible. These efforts have been recognized by the government, emphasizing the importance and impact of the ecosystem. ICO also contributes to the Indonesian timber legality assurance system by ensuring the legality of wood species, helping to combat illegal logging. In 2019, we released the initial version of ICO, which was initially available in Indonesian and had a limited number of supported species. In the second version of ICO, we introduced English language support and significantly expanded number of the supported species and their associated information. As of early May, we're proud to have over 6,000 people. An example of recommended macroscopic photos of wood, cross-sectional photos when using the ICO for wood identification. It is important to avoid the following unrecommended sample photos: those with visible incision mark, blurry or out of focus images, incised lateral surfaces, and visible landscape shadows. ICO is continuously being improved to address the challenges of automatic wood identification. The ongoing development aims to enhance its capabilities in distinguishing wood origin and conducting carbon dating. This progress is made possible through collaboration with various stakeholders involved in the field of wood identification. Together, we strive to provide advanced solutions that meet the evolving needs of wood identification and analysis. This new development opens up the exciting opportunities for further research in the field of wood identification systems. It paves the way for advancements and innovations that can enhance the accuracy and efficiency of wood identification process. With this progress, researchers can explore new avenues and contribute to the development of more robust and comprehensive wood identification systems. In addition to the previously mentioned methods, such as anatomical structure and computer vision, there are various other techniques utilized in wood identification, including DNA analysis, near-infrared spectroscopy, direct analysis in real-time time-of-flight or DART-OF, mass spectrometry, isotope analysis, and Raman spectrometry. In the current moment, an innovative tool and method are being developed which harness the capacitance of wood characteristics. This novel approach holds promise for advancing wood identification and open up new possibilities for accurate and efficient identification processes. By leveraging the unique electrical properties of wood, this method has the potential for contribute to the field of wood identification and offer valuable insights in this area of research. Since 2020, we have diligently working on the development of wood identification tool. By incorporating a volumetric fixed sensor, we have made significant progress. In 2022, we achieved a breakthrough with a tool that can accurately identify wood species in standing tree sort log. This achievement is made possible through the utilization of spectrum analysis and machine learning techniques. With the capability to provide results in milliseconds, our tool offers high accuracy and efficiency in wood species identification. As mentioned earlier, we utilize capacitive-based spectroscopy in conjunction with machine learning for wood species identification to determine the most effective algorithm for our purpose. We have experimented with logistic regression, support factor classification, and key nearest neighbors algorithms. Through rigorous testing and analysis, we aim to identify the best performing algorithm that provides optimal accuracy and reliability of wood species identification. The objective is to create a tool and algorithm that can accurately identify wood species based on capacitive signals. This development will enable efficient and non-destructive wood species identification. In machine learning modeling process involved the algorithm, Logit, SVC, and KNN. The features used were based on PCA, with only 3 features selected. The dataset was divided into 80% training data and 20% test data. ensuring proportional representation of each wood species. The training data underwent cross-validation 3 times with hyperparameters defined for each algorithm. Finally, the modeling results were tested on the unseen data to measure the accuracy of the model. In this diagram, the tool utilized the unique interaction between electric fields and components within the wood, taking into account the impact of its anatomical structure. The figures displays capacitance as a function of frequency, with each line representing a different wood species. This distinct signal capacitance characteristics can be explained by the unique interaction between the wood material and electric field emitted by the capacitance sensor. Factors such as water content, density, and chemical composition influence this interaction, resulting in wood species-specific signal patterns akin to fingerprint in humans. To address the issue of less important information from capacitance measurements and the impact of numerous features on computing speed, the PCI method is employed. PCI reduces the number of features while retaining essential information from the dataset. In this case, the graph illustrates that the first 3 components hold significant importance, resulting in the reduction of the original 6,000 features to just 3. This is the illustration of cross-validation process. It involves dividing the data into separate training and test sets. Then the cross-validation is conducted to evaluate how well the model performed on the test data and to determine the optimal parameter settings. Here, we observe that the accuracy of logit algorithms starts relatively low at the beginning or with lower parameters numbers. However, as the parameter number increases, the algorithm gradually improves and becomes more accurate. This shows the algorithm for superfactor machine, the accuracy reached 85%. The graph clearly indicates that the KNN algorithm exhibits the highest accuracy, particularly with smaller parameters. In conclusion, the KNN algorithm has the highest accuracy compared to logit and SVC. However, we have identified errors in some species. Therefore, we have further worked ahead to improve the overall accuracy. Here are our plans for the future. We aim to increase the size of our database, enhancing its capability to store relevant information. Additionally, we will focus on improving our identification system and enabling it to effectively distinguish the origin and cutting time of various elements. Furthermore, we are eager to engage in collaboration with stakeholders, fostering fruitful partnership for advanced research and application development. This initiative will propel us towards greater success and innovation in our field. And in conclusion, I want to thank you all for your attention and time. Our team is grateful for the opportunity to present our vision. If you have any further question or need more information, please feel free to reach out. Here is an exciting future together. Thank you.